In this lesson, you'll be learning how to solve a rational inequality using a sign chart. Now, much like the polynomial inequality that we began with in our first lesson, in this lesson we want to begin by finding where the numerator and denominator equals 0. So what we're going to do is we're going to factor when necessary in order to do any solving. And it looks like for that numerator we won't need to do any factoring, so I'm just going to rewrite the numerator as x plus 4. The denominator, however, is quadratic, so I'm going to go ahead and factor that, and that'll factor into x minus 5 times x plus 1. Now the purpose behind doing that is to see where the number line is going to have its breaking points. Things will change sign whenever either the numerator is 0 or the denominator is 0. So we're going to go ahead and make a number line, a sign chart, in the same way that we did polynomials. So I'll begin by drawing my number line. And on that number line, I'm going to go ahead and put the places where either numerator or denominator equals 0. So from the numerator, x plus 4 will equal 0 when x is negative 4, so I'm going to put that on my number line. From the denominator, it'll be 0 when x is 5. And the denominator will also equal 0 when x is negative 1. And we can see that by taking this, we break this number line into 4 different regions. And we're going to test values in each region, much the same way we did with the polynomials. So let's start with the region left of negative 4. Let's try, say, negative 5. And just like with polynomials, I'm going to go ahead and plug that negative 5 in each of these places to see whether it's positive or negative. So negative 5 plus 4 in the numerator is negative 1, which is a negative number, so I'm just going to do a negative. Negative 5 minus 5 is negative 10. That's also negative. Negative 5 plus 1 is negative 4. That's also negative. So we end up with, in the denominator, a negative times a negative, which is a positive. In the numerator, we have a negative. So this will become a negative divided by a positive, which is negative. So I'm going to put a negative in my sign chart. Now I'll choose a value between negative 4 and negative 1. I'll choose negative 2. And again, by substituting it in each place, I'd have negative 2 plus 4, which is a positive number. In the denominator, negative 2 minus 5 is a negative number. Negative 2 plus 1 is also a negative number. Now the denominator here will become positive, so we'll have positive divided by positive, and that's positive. Between negative 1 and 5, I think I'll choose 0. 0 plus 4 is a positive number. 0 minus 5 is a negative number. 0 plus 1 is a positive number. This denominator is going to be negative, so we'll have positive divided by negative, which is a negative. Now I'm going to choose that negative and fill it in over here in my sign chart as a negative. Any number in between there would be negative. Now finally, something to the right of 5. Let's choose 6. Any number actually, but 6 is what I'll use. 6 plus 4 is positive. 6 minus 5 is positive. 6 plus 1 is positive. The denominator is positive, and a positive divided by a positive is a positive. Now I've got the sign chart. I just have to analyze my results, and I'll do that based on this statement right here. This statement says greater than or equal to 0. Let's address the equal 0 first of all. Now if this were polynomial, I would just go ahead and fill in all of these dots, all of these endpoints, but in this particular case I can't. With a rational function, remember the denominator can never equal 0. So no matter what this says over here, I will not include the 5, nor will I include the negative 1. If you think about the graph, those would be vertical asymptotes in the graph. X can't be a negative 1 or 5 because that would create an undefined fraction. So the only place it's going to equal 0 is when the numerator is 0. So the negative 4 I will definitely be including. The greater than, well, numbers that are greater than 0 are positive. So in my sign chart, I'll be selecting any place that I have positives. I have positive here and here. So my answer to this rational inequality are the values of x between negative 4 and negative 1, including the negative 4 but not the negative 1, and union 5 forever. And again, I'm not including the 5 because that would make the denominator 0, and I go forever to the right. Of course, we don't include infinity. There's our final answer.